Greetings everyone. Well, welcome to our channel, College Course Solutions Mathematics, and let's get started. So today we are going to be looking at introduction to number systems, and there are mainly four number systems as you can see on your screen. Namely, we have the decimal number systems and binary number system, octal number system, and hexadecimal number system. So what you want to note before we begin is that for the last two, octal number system and hexadecimal number system were created mainly to simplify the second number system, which is binary number system. So they just mainly come up to just simplify the binary number system. Of course, I hope you understand that, and you will come to see on calculations how the octal number systems and the hexadecimals simplify further the binary number system. So let's start with the decimal number system. So this is where it just contains the 10 digits. As you can see on your screen, the 10 digits are from 0 to 9. And of course, whenever you are actually placing the powers in the decimals, you just want to know that to your left, which means it is for normal numbers, not after the decimal. You start from 0, 1, going upward, and when you are counting to the right, which is after a decimal point, you just start from -1, -2, and of course you go -3 and that way and that way. So you will come to see on calculations, especially I would recommend you watch another video where you will come to understand how what we mean by the counting to acquire the powers. The video is called the decimal conversions. The link will be in the description. And so we draw this is what we just simply mean by counting to your left. So you can see the decimal points. So we start from 0. This is when it is to your left, which is not after the decimal point. So we just start from 0, 1, 2, and 3, going upward. But after the decimal point, we start from -1, -2, going that way. So of course, this will be our first and second, third, and fourth. And of course, on this side, just the same. Here we will have 1, which is 10 power to 0. I hope you understand that any number power to 0 is equals to 1. And here we have 10, 100, and 1000. Here we have 0.1, 0.01, and 0.001. And for 10 is to the power -4, we have 0.0001. We want to take an example where you are actually told to represent 632.25 in decimal number system. So what you just simply do, since you can see here is the decimal point, which means from here we start counting from 0, 1, and 2, which means we have 6 times 10 is to the power 2 plus 3 times 10 is to the power 1. Of course, you can see here where we are putting 10 as a base because the decimal have 10 as the base or radix, and we also have plus 2 times 10 is to the power 0. And now after the decimal point, we will start counting from -1 and -2, so that we may have plus 2 times 10 is to the power -1 plus 5 times 10 is to the power -2. Of course, that's how we represent numbers into decimals. I hope you have understood. Now we want to come to the second number system, which is commonly used and mainly tested by the NEC exams, where also the first thing you want to note which is the main factor when it comes to binary number system, is that it will always and forever use zeros and ones. We don't have twos and we don't have any number, we just have zeros and ones. So here is a table for the binary number system. So of course you want to note that it always has a base of radix of 2. So we're going to start with 2 is to the power 0, 2 is to the power 1, 2 is to the power 2, 2 is to the power 3, 2 is to the power 4. Of course you can continue, but I have chosen to leave it at that, so that we have the first position, second, third, and fourth, and fifth. Here you will have 2 is to the power 0, which is 1, and here 2 is to the power 1 is to be 2, and 2 is to the power 2, 4, 2 is to the power 3, 8, and 2 is to the power 4, 16. So that's for the binary number systems. That's how we actually they are introduced. After noting this, you will come to see how we tackle them. I would also recommend another video where we have the link will also be in the description, where we have tackled the binary conversions. Watching the video will make you understand how we come to use the tables and the base and the zeros and the ones. So we want to go to the third number system, which is octal. So on octal number system, I have told you it's one of the delivery number system, mainly to simplify the binary number system. So it actually goes back to refer to the binary number system. And one thing you want to note is that it contains of 8 digits, which are 0 from 0 up to 7. And here, as I have said, it actually simplifies the binary further. So it always has a base of 8, but the base is actually referred to as a 1 octal digit, which is actually equivalent to 2 to 3 binary bits, since 2 is to the power 3 is equals to 8. So when it comes to calculations, as I have said, in order to understand more what we mean by 1 octal digit is equivalent to 3 binary bits, you're gonna need to watch that video I have recommended before on binary conversions, and you're gonna have it is gonna help you understand more. So when it comes to drawing the table, we're gonna have 8 is to the power 0. Of course, it will be 1 as the first position, and 8 is to the power 1 will be 8, second position, and 8 is to the power 2 will be 64, that position. 8 to the power 3 will be 512, fourth position, and 8 to the power 4 it will be fifth position, 1496. The base or radix will always be 8. Of course, I hope you understand that. So we want to go to the fourth and last number system, which is also to simplify the binaries. So this has a little bit of more content, but don't worry, I will explain it all. So first thing you want to note about the hexadecimal number system is that it contains of 16 symbols, which of course the first 10 among the 16 symbols are 0 to 9, and they are just written in numbers, but when it comes from 10, of course the other, after having the first 10, we are remaining with the 6. The other 6 is 10 up to 15, so we just represent them with the alphabetics A to F, which means 10 becomes A, and 11 becomes B, 12 becomes C, 13 becomes D, and 14 becomes E, and 15 becomes F. So you don't want to write a hexadecimal number like 15 as 15. The examiner will give you a wrong, because 15 should be represented by an F and 10 should be represented by A. So that's what you want to note. Whenever you find a hexadecimal number that is greater than 9, which is from 10 to 15, you actually represent them with the alphabets A to F. So as I have said, it's one of the number system created to simplify the binary further, which means since it have a base of 16, one hexadecimal digit is equivalent to 4 binary bits, since binary has a base of 2, which will require to be forward 4, so that it can reach the base of hexadecimal, which is 16. So you want to keep that in mind, that one hexadecimal digit is equivalent to 4 bits, binary bits. So to understand that further, you can watch other videos on our channel, mainly the octo and hexadecimal conversions and the binaries. It will help you understand. Of course, I have told you, whenever we are representing numbers in hexadecimal, of course for 0 to 9 we just write the numbers as they are, but when it comes now to from 10 to 15, then things change, because we just write A, 10 for A, and 11 for B, of course 12 for C, and 13 for D. So that's how we just write it, and we go for 14 for E, and 15 for F. So we just have the table is like this, where we are going to have 16 per 0, which is the first position, is equals to 1. 16 per 1 second position is equals to 16, and 16 2 that position is equals to 256. And 16 per 3 fourth position is equals to 1486. 16 is per 4 fifth position is equals to 65, 536. So that's for the hexadecimal. And the last one, number system, that we are going to be looking at today. Thank you. I hope you understood. Kindly subscribe and hit the bell icon so that you may get notified whenever we post more content on mathematical solution. Thank you.